In this video, we're going to discuss the concept of molality. So concentration is defined as a quantitative measure of the amount of solute dissolved in a given amount of solvent. Now, when we express or measure concentration, there are several different ways to do that. Some common ones are, of course, molarity. We can measure the concentration of a solution as a mole fraction, a mass percent, or as molality. In this video, we of course want to focus on measuring the concentration of a solution in terms of molality. So molality, which is abbreviated as a script m, a little lowercase m, is defined as the moles of solute divided by the kilograms of solvent. So let's compare this to molarity, which of course is a concentration term that we're very familiar with. Molality, which is, we often say we have a molal concentration, so we would have a 1 molal solution instead of a 1 molar solution if we're discussing the concentration. So molality, as we mentioned, is moles of solute divided by the kilogram of solvent. Molarity, in comparison, is the moles of solute, but instead of kilograms of solvent, it's the liters of solution. So in molality, we just measure it in terms of solvent on the bottom, whereas molarity on the bottom here, we have solution, which is the solute plus the solvent. So a very different term there on the bottom of our fraction. So why do we use molality to measure concentration instead of molarity? Well, probably the most important reason is that molality is temperature independent. So we can use molality when we are doing experiments such as measuring freezing point depressions, boiling point elevations, or changing the recording the concentrations at different temperatures. Again, if we look back and compare that to molarity, if you change the temperature of a solution, let's say we have a salt water solution, the moles of solute remains constant and the mass of the solvent does not change. So we can change the temperature from freezing to boiling and the mass of our solvent doesn't change. However, with molarity, the moles of solute, that does not change with temperature. But if we say we're freezing a solution or getting down near the freezing point, our volume can expand and contract, particularly with aqueous solutions. When we get down near freezing, our volume can expand. So we're actually changing the volume, which will change the molarity dependent on temperature. Molality, however, whatever the temperature is, the molality will remain constant. So let's look at a problem involving molality. This says calculate the molality of a solution prepared by dissolving 10.0 grams of sodium chloride in 600 milliliters of water. We're given the density of water. So pause the video and see if you can solve this one. So, as we've said before, we define molality as the moles of solute per kilogram of solvent. So let's define our solute and solvent. We're dissolving 10 grams of sodium chloride, so that's going to be my solute, and my solvent here will be water. So we're given grams of solute and milliliters of solvent. We need to convert those to moles and kilograms. So let's start. I went ahead and put, you can do this in 2 steps if you'd like, and then divide. I'm going to do it all in one here. But I went ahead and put my solute over my solvent and pay careful attention to the units here. So I'm going to change my grams to moles first. So I use the molar mass of sodium chloride, and that's going to cancel my grams, and this will give me moles of sodium chloride. So now I have moles of solute. Now I just have to change my milliliters into kilograms. So Here you can say use the density of water. I've got milliliters on top, so those will cancel, and grams on the bottom. My milliliters will cancel, and now I have grams on the bottom, which is what I want, but I need to convert that to kilograms. So of course, 1,000 grams is equal to 1 kilogram. My grams cancel. And now you can see I end up with, paying careful attention to your units, I end up with moles on top, moles of solute, and kilograms on the bottom, which is the units we want for molality. So now I just need to do my math, and they end up with 0.285 moles of sodium chloride per kilogram of water. So I could leave it like this, or I could write it as a 0.285 molal solution. So either one of these ways would be correct. So let's take a look at another problem involving molality. How many grams of sodium fluoride are needed to prepare a 0.400 molal sodium fluoride solution that contains 750.0 milliliters of water? So again, pause the video and give this one a try. Okay, so the thing I want to point out here is notice that we're given molality and our units are just expressed as a small m. Now, when I'm doing dimensional analysis, and when you are as well, don't leave it like this. Let's express the molality. Let's expand it out so it's moles per kilogram. This will help us when we do dimensional analysis. So as a general rule, it's okay, but do not, I would highly suggest that you do not leave molality as a little m. Write it as moles of solute per 1 kilogram, in this case of water, as our solvent. So now we can use this as a conversion factor, much as we would molarity. So let's start with our volume of water. We have 750 milliliters of water. Now, the density of water, we had that last time, so we need to use that when we're doing molality calculations. So this is going to get our units from milliliters to grams. So this will give us grams of our solute. Next, we can convert that to kilograms of solute. So now I've got my solute, or excuse me, my solvent in kilograms, not the solute, but the solvent is in kilograms. Now I can use my molality as a conversion factor because I have kilograms of solvent, keep making a mistake there. I have my kilograms of solvent on the bottom, and those will cancel, and moles of solute on the top. So kilograms will cancel. Now I have the moles of sodium fluoride. Now I just have to change that to grams using the molar mass. So in this problem, we're using molality much as a conversion factor. So moles cancel, we end up with grams. So pay careful attention to your units. Now we just need to do our math. So to make this solution, we would dissolve 12.6 grams of sodium fluoride in exactly 750 milliliters of water, and that would give us a 0.400 molal solution. So be sure that you're familiar with the concept of molality. Pay careful attention to the units when you're doing problems. Those are key. And practice some more of these so you're comfortable with molality.